This is a hedge for Exxon. You have 100 lots or 10,000 shares. You're selling calls this time. Calls have a strike of 90. The stock is trading at 87. Volatility 17%. And we only know of one dividend on this problem. It's 30 days away, 77 cents. And there's more than likely there's a 77-cent dividend 120 days away, but we'll just work with this one. And risk-free rate's 1.2%. So call formula. We're going to deal with ND1, ND2, the stock minus strike, present value of strike. And I always start again with finding D1, D2. And in this problem, because there's a dividend, everywhere you see the S is going to be what I'd call an S prime, will be the stock price net of the present value of dividends. And so with such a low risk-free rate and only 4 months or a third of a year, the present value of that is almost the same number. So anyways, the adjusted stock price is about $86.23. And you'll see that when we get down to D1 and solving for the Black-Scholes option call price. So our formula for D1, the natural log strike, or stock divided by strike, plus risk-free volatility squared divided by 2, that sum multiplied by time to expiration, and divide by volatility times the square root of time. So you'll see all that here. With the stock price being a little bit under strike, our natural log is a negative, which means our probability is likely to be lower, and our risk-free rate plus volatility squared divided by 2 multiplied by time. Numerator, D1, numerator is 0.0341. Our denominator is, again, volatility, 0.17, times the square root of time. 4 months is 0.33 of a year, so square root of 0.33 gives us the denominator. And numerator divided by denominator is D1, negative 0.3487. We would look that up in a table, and on a spreadsheet it's easy. Here's the up here is the function for a normal distribution, the number, and it's a 0-1 normal property, cumulative 1. So we get 36% for D1, D2, 32.8%. And so we'll be able to use D1, ND2 to find the value of a call. Value of call, we said, was stock minus strike. That should be a minus there. And so here we go. The stock is adjusted stock price. Remember, we came up with our present value dividends subtracted out of the $87 stock price. So 86.23 times your ND1 probability, 36%, less strike. Strike was 90. Present value of the strike, because it's in the future and we want to know the value today, and multiplied by the probability of that event. ND2 is 0.328. The difference, 199 per call, multiplied by 100 for a call contract, so 198.50 roughly for a contract. And to hedge with, each share of stock, you would sell 2.75 calls. For 100 lots, you would sell 275 contracts to properly hedge. And Exxon, with the dividend, 10,000 share position. And that's the Black-Scholes call hedge for a dividend paying stock.